Hello everyone! In this lesson, we'll talk about collision in Dragon Breath ribbons. When we're working on shots or creating animation, it often needs to collide with the body, head, and legs. For collision, the main parameters are located here. We have three types of collision objects that can be created. This one is a capsule. This one is a cylinder. And this one is a plane. You need to pay attention to this plane. It collides with the surface facing the positive y-axis. Let's do a simple test. For example, we already have an animation here. Normally, it would just pass straight through. Then we create this sphere. This sphere must be created from here. Its name follows a specific naming rule, then it will participate in collision. Let's try it. You can see it slides over the sphere. This is a single collision object. You can also use multiple collision objects. For example, we duplicate this one and place it here. You can see it becomes a combined collision effect. For collision, there's no need to manually enable anything. As long as collision objects exist in the scene, they will automatically participate in collision. If we adjust this a bit and move it in this direction. For collision, there are two parameters you need to pay attention to. One is the solver steps. The other is sampling density. What do these parameters mean? Solver steps mean how many times the solver runs per frame. Normally, once per frame is enough. But if the motion is very fast, for example, it's here in the previous frame and already far away in the next frame, then collision won't be detected in between. To catch that collision, you need to increase the solver steps. For example, setting it to 10. Means solving once every 0.1 frame. It checks collision more frequently. This way, the result will be more accurate. The other parameter is sampling density. Sampling density exists because our bones have length. If sometimes the bone is very long, and we only use the two endpoints for collision, the collision result will be inaccurate. Sampling density adds extra points in between. If the bone is very long, you can simply add more sampling points. Let's look at an example. I'll delete the animation first, and then make this object move very fast. For example, in 2 or 3 frames, 4 frames, it moves past very quickly. It moves a long distance. In this case, there's only 1 frame for collision detection, and it may fail to detect it. Let's try it. Here we lower the softness a bit. You can see it passes straight through. Then we increase the solver steps. Let's check again. This still doesn't show clearly. Wait a moment. Let's make it pass through in 1 frame. Even shorter. Now it passes through in a single frame. If we set this to 1, it won't detect collision at all. Right? It completely misses the collision. Now let's set it to 10. It detects the collision in the first frame. Then it moves backward with a dynamic response. Finally, one more thing. Collision objects also include the plane. Let me create one. Let's make a simple animation here. This plane is often used to simulate Things like skirt hems, dragging on the ground. It works quite well for that. When it hits the ground, it no longer sinks downward. That's the basic collision setup. Thank you, everyone.